Hi, everybody. Thank you for those of you that are joining us today for this virtual track session. So the overall theme of the track session is basically um, increasing improved seed adoption in the Global South. And the papers we'll be presenting today are well, first, Barbara will present sort of an overview literature review about different seed adoption strategies, and then the next three speakers, Sergio Puerto, then Manaswini Rao, and Eric Zhu, will talk about sort of different specific case studies of innovations. So Barbara, take it away.
Thanks so much. Yeah, so my name is Barbara Kramer. I'm a senior research fellow with IFPRI based in Nairobi in Kenya. And this is joint work with Carly, as well as Lucy Schultz, who is working with us as a collaborator, and research support from Emily Kulonzi, who is a research analyst in our IFPRI Kenya office. So I'll be presenting a meta-analysis on interventions to increase adoption of improved varieties. And I want to caveat this with that this is still ongoing work, and that results might be subject to change, just the usual research process happening here. All right. So let me jump in to why we're doing this work. Millions of dollars are being invested every year in plant breeding efforts for the Global South. So for instance, in 2018, the CGER spent $824 million on R&D, and a large proportion of this funding is going into public plant breeding programs. But unfortunately, the adoption of improved varieties coming out of these breeding programs remains low. For instance, in the period 2016 to 2020 in sub-Saharan Africa, only about 33% of cropland was planted with improved varieties. Now, and that 33% is also including very old varieties that have been coming from breeding programs in the past and that may have been released 15 to 20 years ago. And so a lot of the genetic innovation is not making it into farmers' fields. So there's many possible interventions to increase adoption of improved varieties, including providing resources, for instance, subsidies on seeds, credit, or improving seed supply to bring down the cost of seeds locally at the farmer level. Also providing information or better farmer coordination mechanisms, for instance, cooperatives that make it easier to buy seeds in bulk and overcome transaction costs. But we don't really know how these different interventions compare to one another in terms of their impacts on adoption. And it's a lot of isolated different studies that have been done, and we know little about the external validity of these individual studies. And so because of this lack of systematic evidence on which interventions are most effective, we decided to do a meta-analysis of the literature on what interventions can help increase varietal adoption and also varietal turnover, getting farmers to plant newer varieties. So the objective of this study is, first of all, to identify the most effective intervention types to promote adoption and turnover. Now, second of all, we are interested in documenting the costs of accelerating varietal turnover with particular traits. And the idea here is that if breeding pipelines are faced with decisions on whether to invest in a pipeline, they would need to know not only what is the cost of breeding itself, but also what is the potential adoption and the potential cost of these varieties getting adopted. So with that in mind, we were very keenly interested in also documenting the costs, but unfortunately, a lot of these papers don't really report on costs of the interventions that are being tested. So for now, it looks like we have to drop this study objective and reach out to authors to see if we can still collect those costs and be able to include that in the study. So that's still work in progress. Another objective is to quantify average effects of interventions to promote new varieties across a wide range of contexts. So to aggregate the evidence on individual effect sizes into one average. but then also to look at whether there's heterogeneity across evidence quality and whether there's consistency in estimated effect sizes across studies with different methodologies being used. And finally, we aim to highlight research gaps and inform policy. Okay, so as we did the meta-analysis, what studies did we include? First of all, of course, we were interested in studies that looked at interventions to increase adoption or turnover of improved varieties, and thereby focusing on studies conducted in the global south with a focus on smallholder farmers. They had to assess the effectiveness of seed-related interventions, so more generic interventions that do not really have an objective to improve adoption of varieties. We would tend not to include those. And we also focused on studies published in English. In terms of exclusion criteria, so we really focused on studies that had variety adoption as an outcome. So some studies would just report improvements, for instance, in knowledge or perception of varieties, and we were not able to include those as our main outcome variable was really the behavioral outcome that a variety needed to be planted or adopted. We restricted ourselves to the plant kingdom, not including livestock breeds or tree species. And we also focus on improved varieties and thereby not including studies that focus on promoting local varieties that have not been improved necessarily through breeding program efforts. And related to that is also that we exclude studies that focus on informal seed business promotion strategies because these were not always promoting improved varieties and oftentimes increasing the production of quality seeds of local varieties. So that's a bit on our inclusion-exclusion criteria. Here you see the databases where we did the search. This resulted in 2,675 studies that we then trimmed down based on a review of abstracts to 512 studies for which we did a full text review. And then there we applied our inclusion and exclusion criteria, and this trimmed it down further to 263 studies. Now, for those 263 studies, we tried to extract key variables that we would need to do our meta-analysis, which includes things like effect sizes, standard errors of those effect sizes, sample sizes, those kinds of variables. But these were not available for all, and so that left us with 209 studies that are included in the final data set. Now, many of these studies actually evaluate the effects of multiple interventions and present multiple treatment effect estimates. And so that gives us 502 observations in total because we look at sort of the intervention level as an observation. So we have 502 observations in total. Okay, here you see where these studies are coming from, these 502 or the 200 something observations. And you'll see that they're primarily coming from sub-Saharan Africa, to some extent also Southeast and South Asia, less so from Central Africa, Northern Africa, the Middle East, and also in Latin America, not a lot of studies. And we have some very popular countries in the African continent, as you can see. So this is sort of, key to highlight that there's quite a geographical concentration of where this type of research is being done. Then in terms of analyzing the data and estimating the average effect sizes, we use both a frequentist approach and a Bayesian approach. So we use a statistical package for meta-analysis called Metaphor, which is random effects meta-regression with maximum likelihood. And there we're looking at moderators such as intervention type, crop type, evidence quality. And when we're looking at the Bayesian analysis, we're using a software package that is called Bagger, which is available in R. And this is hierarchical modeling of effect sizes. And we adopt weekly informative priors in this Bayesian approach. The advantage of the Bayesian approach is that when you have a smaller number of studies, by using priors, you can help increase precision to some extent, as the priors help with the estimation. But the downside is, of course, that you need those priors. So we'll be presenting both frequentist and Bayesian estimates. And we're interested in heterogeneity by intervention type, crop type, and evidence quality. All right, here you see sample sizes. The average study has a sample size of 828, but this is heavily right skewed, and the median study actually has a sample of 479. So some of these studies are with fairly small samples, and really aiming to understand just adoption. And maybe not necessarily having the sample size to go further downstream from adoption to impacts. And it might be a question that is coming up later. So just wanted to share this. Then in terms of intervention types, we have farmer coordination mechanisms. It's a large number of studies that are looking at what is the effect of forming cooperatives or marketing through cooperatives on varietal adoption. We have a lot of information interventions as well, with the bulk being extension and looking at what is the effect of providing extension on the adoption of improved varieties. Fewer numbers are focused on agricultural training that is sort of standalone from extension and information campaigns. And then finally, we have a set of studies that is focused on resource interventions, including providing access to credit. That's the bulk of them. A smaller number of studies, but still a fairly large number that focuses on improving access to seed supply, and 11 studies in our sample are providing subsidies for seeds. So here is a first descriptive statistic where we're showing the adjusted effect sizes. Yeah, as you can see, there's a bit of a right tail. We see that it's sort of skewed, which could reflect a sort of publication bias in that only studies with a positive effect size make it into the literature. But at the same time, there's also challenges in converting our effect sizes from probit and logit models into these adjusted effect sizes. And so if you have any questions on that, please let me know, and some of my co-authors might be able to help answer questions around that. Now, this is the main result. We see that in the frequentist approach, the interventions on average increase adoption by 10 percentage points of improved varieties. And with the Bayesian approach, we find a very similar statistic. So the results from the frequentist and the Bayesian approach don't vary too much from one another. Also, if we're looking at other statistics in the table, fairly similar to one another. But so here, the bottom line, if you look at the confidence intervals, is that on average, these seed promotion interventions really have a strong and positive effect on increasing varietal adoption. Here we see the effect sizes by intervention type, whereby you see that improving access to seed supply actually seems to have the largest effect. But overall effect sizes are positive across all the different types of interventions that we found in our literature review. With access to credit being the smallest effect size, but also that one still being significant, positive, and not significantly different from a lot of the other effect sizes that we see across the board here. Then we see by crop family, very similar, also positive effects across crops. Interestingly, even for cereals. And I'm saying that this is interesting because a lot of the cereals will be maize, for which seeds will be hybrids. And it will be difficult for farmers to kind of keep planting these because they would need to purchase new seeds in order to access these varieties. Because with hybrids, it tends to be not recommended to be recycling. And so it's very interesting that we see very positive effects across each of these groups, and none of the effect sizes are significantly different from one another here. So it's a fairly consistent and general pattern across different crop archetypes or families. Then evidence quality. So unfortunately, we only found 4 experimental studies. And so we need to look more into this and see if we can bring some of the quasi-experimental studies into a same category with experimental studies, that we have a larger sample size there of perhaps more rigorous methods, with some of the quasi-experimental studies having less rigorous methods and being presented as a separate group. But overall, what we see here is that even across evidence quality, there is not a lot of heterogeneity and different study methodologies, all of them finding positive effects. So then that brings me to some preliminary conclusions, again, caveating that this is early work and that findings might change, but we're finding a very strong, positive, and consistent effect on seed adoption across models. We're also finding that this is consistent across crops. There's a lot of variation across studies, though, so other moderating factors might be at play. And finally, I mentioned that costs tend to not be reported, and that's a large gap in the literature because it makes it difficult to draw conclusions regarding the cost effectiveness and what the costs would be of promoting varieties with specific traits, and getting those into farmers' fields. So I'll turn it over to Carly there.
Thanks, Barbara. Great presentation. We have a few minutes, so we have some questions in the chat from Manaswini. She was asking how evidence quality is measured, what the unit of observation is in the and what the unit of observation is in the samples, so either individuals or like cluster level analysis.
Thank you, Manaswini, for those questions. So we measure evidence quality for now by looking at whether a study is observational or correlational, versus whether they use quasi-experimental methods, which would include propensity score matching, instrumental variables, difference in difference estimators. I think those were the largest groups. And then finally, we have a group of experimental studies, but we only have 4 experimental studies in the sample now. So we may want to dive a little bit further into the quasi-experimental group, which is quite large, and for instance, distinguish those that use propensity score matching from, for instance, instrumental variables and difference in difference, which would arguably be a bit more rigorous than a propensity score matching approach. In terms of the unit of observation, so a unit of observation is a treatment effect that has been reported in the literature for a specific intervention. So if we have, for instance, a study that is looking at the effect of, let's say, extension versus a seed subsidy, then, and presenting an effect size for those two, then that would yield us with 2 observations. And so, yeah, both the seed subsidy would be an observation and the extension would be an observation. So that study would give 2 observations. Other studies might just be evaluating one intervention, and then we would have just 1 observation from that study. So yeah, individual sort of treatment effects are our unit of observation. I hope that clarifies things.
What I meant, sorry. Thank you for that was a great presentation. And having done a bunch of work in agriculture technology adoption, like I really appreciated this whole, the map and sort of synthesizing the results. So that's really great. Thank you for doing this. I think this is very valuable. What I meant by evidence quality is like I completely understand. One dimension is to look at sort of the causal, like how good is the confidence, how good is our confidence in the causal inference of these estimates. And I know that like if the experimental evidence is just coming. Like I think in the last 10 years or so, maybe from what I remember, I think the JPAL, like the agriculture technology adoption, they have curated. I don't know if they directly map to like seed adoption per se. Like it's broader for agriculture technology. So, so that's just one dimension of evidence quality. I was thinking that maybe precision or standard errors around these treatment effect estimates could be another, and are you like differently weighting that?
I see. Yeah.
And then I
Yeah.
also
So in
found,
the meta-analysis method, that is
yeah,
being factored in. So a more precise study with a higher sample size
okay,
would receive, in a way, a higher weight in the
yeah, yeah.
analysis. Yeah.
And that's what I meant by sort of observation in the sample of the study. I
Yeah.
know that in your meta-analysis, your sample N is a particular treatment effect size.
Yeah.
But like, so again, the underlying study that you're drawing these from would have like different sample size, and some of these could be where the intervention is introduced at an individual farmer level, and or it's at a cluster, right? Like they're working in like
Yeah.
200 villages, and so all of that could kind of affect your treatment effect interpretation. So that's what I meant, and like those could also, all of them could go into the meta-analysis.
Yeah, I think that's an interesting point, and thanks so much. I think we can provide more descriptive statistics to show how by intervention type,
Yeah.
maybe the sample sizes might differ and the way of clustering, if randomization is done at or treatment is offered at individual versus cluster level. So yeah, we can look more into that. Thanks so much for that suggestion.
Great. So there are more questions, but I think we might want to move on for the sake of time, and potentially if we have time at the end, we'll do some more, but I'll turn it over to Sergio now.
And maybe if there's more questions, also feel free to type them in the chat, because
Yeah,
I'll
that as well.
be able to respond in the chat as well.
Perfect. Can you allow me to share my screen,
Yeah.
please?
There we go.
Perfect. Can you see my slides now?
Yes.
Good. Well, good morning and good afternoon, everybody. My name is Sergio Puerto. I'm a postdoc at the Center for Effective Global Action at UC Berkeley. And today I'm going to talk about innovation and technological mismatch in agriculture, or using the case of improved seeds. Um, um, I'm going to start with that fact that almost every paper on technology adoption in agriculture is pretty much motivated by the same or the version of the same puzzle. That is that we know that innovation and technological change in agriculture is fundamental to economic development because it increases farm productivity growth, income, and improves food security, and one of their very desirable outcomes. But for some reason, poor farmers are still reluctant to adopt seemingly new and improved technologies, inputs, and practices. Economists, of course, have studied this for a long time. We have names for it. For example, Suri calls it the technology adoption puzzle in agriculture, although it happens in other areas. For example, energy savings technologies in developed countries. It's a similar story. And the main explanation in the literature is there are a number of demand side factors or contextual factors that affect farmers' technology choices, from too much risk aversion, learning failures, liquidity constraints, and so on. And this has created this narrative about farmers' failure to adopt new technology. However, it is often overlooked that new technologies usually or rarely tailored to the needs of and preference of poor farmers. For example, the bulk of agricultural technologies, fertilizer, improved seeds, are usually produced for the context of high-income countries or research-intensive countries. So when these technologies are applied to, let's say, in the context of a poor farmer in the tropics, these technologies tend to be less productive. And at the macro level, we have a pretty good understanding of the impacts of inappropriate technology and mismatch. But in micro development, we know much less about this issue. So in this talk, I'm going to talk about two related experiments. One is a randomized controlled trial that was part of my joint market paper, in which I tried to test an alternative explanation for this hypothesis, in which I argue that these biases in research and development create a mismatch between the attributes of new technology and the preferences of farmers. And in a second related experiment, I'm going to show you preliminary results about a follow-up survey and randomized control trial based on DNA identification of new varieties. So in the first experiment, the goal is to estimate the impact of this technological mismatch. And to do so, I designed a two-stage randomized evaluation. This design is inspired by personalized treatment assignments, in which first you learn something about the subjects in the experiment, and then you use that information for treatment assignment or to modify your experiment. So in the first stage, I selected a random sample of 800 farmers in Costa Rica, and half of these farmers were assigned to an evaluation group. These farmers participated in agronomic trials on their own farms, with drought-resistant seeds that were developed by the National Breeding Program in Costa Rica. And the goal of the evaluation of this evaluation on farmers' fields is to give them the opportunity to test the variety for a single season and given some structure to do this evaluation. The goal is twofold. One is to estimate the true performance of the new seeds under the real life conditions of farmers. And here I'm talking about common beans. In total, we have 5 new varieties that were developed as potential candidates for a new variety of red common bean to be released by the National Breeding Program. One of them, which was actually released in 2023. But what we learned from stage 1 is that all these candidates were very promising in terms of many attributes, particularly yield, but no single variety was just the best on everything, which makes sense. At the same time, for farmers for which certain characteristic is more important than yield, these varieties are just worse. For example, maturity. Based on the data from these agronomic trials in which these farmers tested the new seeds, we learned that maturity in particular is not better, if not worse, than the reference variety, which is a variety commonly adopted in the country. We also learned that this CEF71 variety is the best overall within the set of new varieties, which makes it a potential candidate for a new variety to be released. Now, this is within the set of new varieties, but we think about technology adoption, particularly improved seeds, as a replacement process in which farmers will replace the current seed versus a new alternative in the market. So when we consider the outside option of a farmer comparing between the set of new varieties versus the existing seed that they use in the market, we learn from this data that the new seeds are just less preferred than the farmer current seed. So it is dominated in terms of stated preferences. There are many reasons for this. Some of them might be related to some explanation that I mentioned at the beginning. The important point is that this is already telling us something that perhaps the benefit or the potential improvement that the new seeds bring is not good enough or large enough to trigger adoption. Based on this information, in stage 2 of the experiment, we came back to each farm and visited farmers to offer a small quantity of a single new variety. And I randomized these offers in 4 treatment arms. The first one, which I call the farmer choice group, is composed by farmers who participated in the agronomic trials, so we know what variety they like, and we are going to match their preferences by offering them exactly that. The second group is the breeder choice group for farmers that participated as well in the agronomic trial. So we know again what variety they like, but we're going to offer them something different. And that something different is a variety chosen by the scientists as a blanket recommendation for all farmers. The third group is the reference group, which is composed of farmers who also receive the recommended seed. And this is the business as usual scenario in which farmers have no prior experience with the new seed before making an adoption decision. But it's the more reflective of what a normal situation, once the variety is released by the National Breeding Program. And finally, have a pure control group of farmers who did not participate in the trials and didn't receive any magic beans. So I'm going to use the information from the farmer choice group and the breeder choice group to estimate the mismatch effect, because as you can see, the only difference between the two is the variety they receive. I'm going to use the reference group for controlling the participation in the agronomic trials. Here I'm showing you the treatment effects on take-up. So I'm showing you the take-up rates across experimental group. And as you can see, the farmer's choice group has the highest take-up rate of about 60%. So when we went back to the farm, we offered the chance to buy the new seed. So 60% of farmers bought a small quantity of the seed that we offered, compared to the breeder choice group, which was about 40%, which this means it's like a 18 percentage point difference between the two, which is what I call the mismatch effect on adoption. I find no difference between the reference group and the breeder choice group, which tell us something, or at least should tell us something about farmers' learning and willingness to participate in citizen science that we call it, allowing farmers to test the new seed on their own fields. But I will talk about that later, or perhaps later for the discussion. And the horizontal line is just like a reference point, capturing the average of the rate of farmers that bought certified seed during the season, which we made these offers on the new seed. Because in the case of beans, farmers can save seed from a previous season and continue using it for later season. The problem is that quality tends to degrade, so there will be a point in which they need to buy new seed, which is certified seed. So either they go to the market to buy certified seed of current varieties, or in this case of the experiment, they will buy a new seed from us in the experiment. So what potential explanations are from this mismatch effect on take-up or adoption? By design, I created these randomized evaluations such that I was able to control, at least to some extent, for common adoption frictions and constraints, liquidity constraints, access cost, differential learning, and quality misattribution in particular, because we went to each farm, we offered the varieties at the gate, we asked them to focus in particular attributes for which they could learn the true performance of the new seed, and they could always compare the new seeds versus the reference variety and their own seed at the farm, at least in one season. Ideally, we'll have to have more seasons so they can test it more, but that's just a lot more expensive to run. Using the data from stage 1 and other parts of the survey, I also rule out demand-side effect factors or explanations for this effect. One is whether farmers did pretty well in the agronomic trials, which should drive adoption in the second stage. And I find that yield alone is not a good predictor of adoption. So there are other attributes that matter to farmers. As I said before, participation in the agronomic trial was not particularly significant in terms of differences in take-up rates. And I also study farmers' beliefs on performance at baselines and after participating in the agronomic trial, just to get a sense whether farmers think that, or how much farmers believe that a new variety should bring in terms of performance in order to trigger adoption. And I don't find that farmers are particularly biased in terms of beliefs, and I don't find this is particularly important to explain the story. So I would argue, and this is based on a model that I built from a HANA learning model, that mismatch is, and this is one of the main results of the model, that mismatch is correlated to certain aspects, and particularly location-specific characteristics and technology attributes that influence research costs. And the underlying idea here is that if a scientist has a hard time adopting a variety, or it's very expensive for him or for her to adopt a variety for a specific place, we should expect that mismatch is a lot larger in that specific location. Or maybe scientists at the National Breeding Program are really good at reading farmers' preferences and then design a variety that match what farmers really want. In that case, we should expect that this technological mismatch is a lot lower. I find some compelling evidence for this result. So here I'm just showing you in the left most panel, the 18 percentage point estimate. In the middle, I'm using the distance between each farm location to the research lab where the varieties were developed. And I'm showing you how this coefficient changes. So as you can see, for farmers in Quintal 1 who are very close, or at least closer to the research lab where the new seeds were developed, I don't see a mismatch effect, or as the estimate is almost virtually zero. But for farms that are farther away, you observe this negative effect, and it gets stronger the farther you go. I don't have a lot of power to test this result in a most robust way, but at least it's some compelling evidence about what is going on in terms of mismatch. I also study extreme weather, in particular the drought, because remember that the competitive advantage of this new seed is drought. They all have different characteristics in terms of seed color, plant structure, and so on. But the point of this breeding cycle was to develop a new drought-resistant variety. And when I study dry spells and drought losses or other drought events using survey data, I don't find that this coefficient changes. And here it could be like an artifact of the data, because in the particular season where we did this evaluation, drought was not particularly relevant. So perhaps in that season, it was about 4% of farms who experienced some drought. So it doesn't seem like it was a relevant problem for them. But I used dry spell data for 3, 5, and 10 years to test whether those who are exposed to drought in longer periods are also more willing to adopt the new varieties, and I don't find any effect as well. I should also say that it's not only about adoption. I do find that farmers who adopt the new seeds, the most preferred seeds also experience high, or at least higher productivity gains compared to those who adopted the recommended seed. So for those who were recommended or were offered the recommended variety by scientists, I don't see really an impact in terms of yields, but those who adopted the preferred seed, I see an impact of at least 3.75 quintals per hectare, which translates to about 31%. I don't believe this effect is so large as 30%. It will be like a magic bullet to increase productivity. And I believe it because these experimental plots are a lot smaller. So I expect that once you increase production to a larger scale, this estimate will decrease. But I do think that at least some of the difference between the recommended and those who adopted the preferred seed will remain. But I guess it's something that we can test over time once these new varieties are widespread in the country. Now, I just want to mention a few things about a follow-up RCT we are running. I think I'm good on time, and I'm going to show you a couple of things. So one, something that I wanted to do, and this is building on some of the limitations of the original experiment, is that measuring adoption as take-up is just a weak measure of what we want to learn. So we conducted a 12-month follow-up survey and an additional RCT to get a better sense of what happened with this variety once we release them to the public in the sample. Of course, I spent a lot of money and effort to track the varieties during the original experiment to really know where they were planted and how much they produce and so on. But after a year, it's pretty much impossible. And there is a lot of evidence showing misidentifications of new varieties in self-reports by farm. So I could go back to the farm and ask, do you have the seed that you bought a year ago? But likely they might not know they're planting the same seed and so on. So we work with the scientists and we wasted quite a bit of money to develop a DNA fingerprinting protocol to be able to have a more accurate measure of what varieties are being planted. And also, and more importantly, we created a reference library of all varieties that are planted in the country that were part of the catalog of the National Breeding Program. So I'm very proud of this because this is not a product for this paper in particular, but it's like a public good for the country. For the paper in particular, it will give me something that I really wanted to have. And instead of having these like rough measures of heterogeneous mean effects based on distance, I can use the genetic distance between the varieties that farmers are planting versus the new seed and make sure that whether that difference matters in terms of adoption, which I'm not going to show you here because this is something I'm working on at the moment, but it's a benefit of having this rich information. Although I should say that in terms of fingerprinting protocols, there's also so many degrees of freedoms that scientists have and decision they need to make that the DNA fingerprinting is not just like like a magic silver bullet that will tell us exactly what variety is being planted because there's a lot of things going on. And on top of this data work, we run an additional randomized control trial in order to understand what would be the information gains of going back to the farm and ask them what varieties are you planted, and comparing an intra-household design in which we ask several people in the same household, in particular women in the household, which are usually ignored by agricultural economics methods. So usually we go to the household head of the household, and on average they are mostly male, so we ignore other people in the household who are perhaps important in terms of agricultural production. So we are trying to test how much information we gain in terms of variety identification by including other people. I'm not going to show you this here, but this is work with Martina Celli, Ale Tufan, and other scientists at Cornell University. And with this, I just wanted to show you what happened a year later with these varieties. So at headline, the percentage of plots planted with the new seed was 19%. And a year later or so, let's say 12 to 14 months, we see that this percentage drops to about 8.4%, which is not surprising, but a bit depressing. I was expecting to have at least a higher percentage. The good thing, or at least something that is promising, is that we included new farmers from the same villages in which we offer these varieties, and we see new farmers using the new seed. 3.6%, but at least there are some doing so. In terms of differences in the experimental groups from the original experiment, Those who adopted the preferred seed have a higher percentage of prevalence of the new seeds, although the differences are less dramatic than I expected, or at least compared to the original experiment. So one is 9% versus those who got the recommended seed is 6.4. It's still 30% higher, but the magnitude is a lot smaller. I don't have, again, the power to test any of these differences, but it's some evidence about what happens later, and also an indicator that adoption is really hard to achieve, especially in the long term. And finally, in regards to the planted area, it's about 43% of the total planted area in the sample that is planted with the new seeds. And this is just an artifact of the fact that the new seed has a limited supply. So these are seeds that were released by the breeding program. These are there's only a limited quantity of them around. So the plots that are planted with the new seed are much, much smaller still a year later. I think the average plot size for the new seed is less than an hectare, like 0.9 hectares, and a regular plot will be 1.6 hectares. And just to finalize with some discussion points, in this paper, well, at least in my research throughout these experiments in Costa Rica, I want to highlight that I do believe that technological mismatch significantly reduces adoption and productivity of new technologies, in particular new seeds. And this highlights a very important trade-off between innovators' priorities and farmer needs. These are plant breeding scientists that have specific mandates in terms of what the seed should achieve in terms of, for example, climate adaptation, which is a very long-term objective, whereas farmers may be worried about the specific season they are at the moment, or perhaps the next one. So those priorities are different, and managing and being able to align both priorities is a very important policy task. At the same time, I don't want you to think this is just about some scientists in Costa Rica, because this strategy of one-size-fits-all strategy is very common and affects many plant breeding programs globally. And a specific example is this farm input subsidy programs, in which you get a bag of urea, a bag of new seeds, and that's like for everybody the same. I'm not saying that's wrong, because that has some benefit, but most of the evidence that we have in this case, it seems to suggest that the benefits or the potential benefits of these programs is very limited. And I'm just like listing some policy implications that are perhaps more relevant for plant breeding people. But in general, I think this problem can be solved with like some market-based solutions. But at the same time, we need to make plant breeding stronger and invest more resources to allow the scientists to get to know farmers better. Thank you. That's all for me.
Thanks so much, Sergio. I think for the sake of time, we'll have to move right into Manaswini's presentation, but there's some comments in the chat that are interesting. You might want to check those out. So go ahead, Manaswini.
Hi, can you hear me?
You're a little muffled, but we can hear you.
But this, yeah, I'm holding the mic.
Okay, that's
closer.
better.
It's fine, right?
Yeah.
Okay, all right. Okay, thank you, everyone. I'm really enjoying the set of talks here. It's so related to like specific agricultural seed technology adoption. So this paper is sort of looking at this whole process of seed adoption and diffusion, using the lens of social structure, like local social structure, and how like the technology spreads from sort of initial recipient farmers who are given these mini kits or small who are actually directly sold or provided for free or with subsidy this technology, and how does it spill over to other farmers in the same village or same communities. So yeah, I don't think I need to spend a lot of time motivating the importance of this question. Everybody has sort of covered all the points that I have, except the thing that I would sort of bring attention to is the time factor. I mean, we all know that technology adoption has an S-shaped distribution, and typically it plateaus at very, very low rates. As I've seen, like, there's some kind of common theme of 10% is some kind of magic number where all this technology is plateauing to. And These delays and the extent to which the level at which it plateaus could have a significant economic cost, like from sort of growth and macroeconomic perspective, right? And so this is still a big open question in literature as to like, this time delays as well as sort of the overall level of adoption being so low. And is it because of suitability or profitability of the technology? Like Sergio talked about mismatch, and there's could be many other reasons like preference mismatch and like, learning deficiencies and all those things versus like market failures, like, Tavneet's, Suri's work on access costs and so on. So there are these sort of broad classes of like, factors of why like we see such low levels of adoption of profitable technology. And typically, these sort of technologies are externally introduced by, institutions like CGIRs, IRI, or whether if it is for rice or other types of the other scientists who are like working on improving the variety for various characteristics, and then they go after agronomic trials, they go enter the field and work with a bunch of farmers to introduce these technologies. So typically it's, who these initial farmers that these breeders or scientists contact happen to be elite farmers. They're like, you either call them progressive farmers who have repeated interactions with, these seed breeders or scientists. And, one could think about, hey, this could lead to distributional concerns. Maybe these elite farmers already have like better practices, and the gains from introducing new variety may not be the most optimal. For example, if you could target to farmers that have higher marginal product from adopting those varieties. And so there are these newer studies that focus on different types of innovation strategy, and some include even randomly seeding and randomly distributing this technology to different farmers. And then some strategies are more effective than the other, right? And so we still don't know a lot about like what works and what doesn't work. And so this paper tries to take like, contributes to a small part of this open puzzle by focusing on rice. So it is part of the CGIR institution's work. So our partner has been IRI, the International Rice Research Institute. We worked in eastern India, which is a paddy belt, and it's extremely flood prone. It's a very low lying land, and it kind of abuts the Bay of Bengal. And it's, you have every year there are these what's hurricane in the US is a cyclone in that side of the world. A lot of the farmers are smallholders, right? Like, it's not a surprise. About 30% of cultivated rice or paddy crop is prone to flood damage, right? And 3 days of flooded fields is sufficient to see yields drop. And these are all from agronomic trials. And then it could also have substantial welfare implication, where like rice is an important staple, like, a crop that families eat on a day-to-day basis. And if you see like 30% of your crop being washed out, then that kind of reduces how much food you can have for your meal. So what we do here is leverage the fact. So we build on an original study. So the original study by Kyle Emmerich, Kyle Emmerich, and two of my co-authors, Alan and Betty, did an impact evaluation of a new flood-resistant paddy variety developed by IRI in across 128 villages in 2 flood-prone districts in Odisha. So that impact evaluation followed a 2-stage cluster randomized trial, where on the one level, half of the villages in the study sample were assigned to treatment, which received the seed technology, and the other half, 64 villages, were controlled. And each of the treatment villages, 5 farmers were randomly selected from a group of paddy farmers, and who were given these mini kits, as they call it, which is, the new varieties. They were given 5 kilograms of these mini kits for them to kind of adopt that season and subsequent season. And then they measured yields and cost of production and so on. And so the paper that was published in 2016 showed, like, using this sample, showed remarkable productivity gains in field setting. And I'll talk a little bit about this technology and how these productivity gains were witnessed. This paper goes back to the same villages, relying on the same experimental design from earlier. And we go back 5 years later to kind of then see how did this technology diffuse to other farmers in the same villages, other than those who were initially given these mini kits, right? So we try to trace out the longer run diffusion of this technology, which was shown in the impact evaluation to have large effects on productivity. And then we see how does it subsequently diffuse among other farmers. So a little bit about the technology. So the technology is called Swarna Sub 1. So commonly used paddy variety in this area is called Swarna. So 70% of all paddy farmers grow this Swarna variety. And then the new technology was like a small modification to the genome of this Swarna, which increased flood tolerance. So it's called Swarna Sub 1. And so so the expectation is that, this is remarkably similar to Swarna, which has been grown for decades in this area. So people should immediately be able to switch because this technology provides flood resistance. So the impact evaluation found that the seed technology had persistent gains. So not only during flooded years where the productivity went up, yields went up, but the yields also went up in normal years when there was no flood. Right. And one of the key reasons why this happened is that this technology provided an insurance mechanism and led to factor deepening. Farmers sort of, improved the cultivation practices, used more fertilizer and so on. Right. And so the expectation, like when we went for the long run, I'm going to skip the literature review. So the expectation was that, okay, if this had such a big impact even during normal years, then it should just immediately diffuse, particularly to the marginal farmers who have flood-prone lands, and they should just be lapping up this technology. So we went back 5 years later. We did a census of all other paddy farmers outside of these initial kit recipients. And we could only go to 100. So we couldn't go to 2 villages because they were flooded, but we checked for attrition and so on. And we conducted a very short survey because we trade off for the quantity. Like we had 9,000 farmers with sort of how much time we could spend with each of them. So we just had a short survey on cultivation decisions, area grown, what variety did they use over the last 3 to 4 seasons. So over the last 3 to 4 seasons since the initial introduction of the study. So we exploit the experimental variation from the initial study, and sort of any characteristics of these villages or these farmers are at least predetermined because that's what we use and kind of trace out. So the specification is relatively simple. For this talk, I'm going to focus on just the adoption of the new variety by treatment status, and then we map it out over 5 cultivation seasons from initial. We also look at how much the area under that particular variety changed at that village level over time. We also look at the source of the seed. How did the seed transfer happen among the adopters? How did they acquire the seed? Did they actually go to the market, or did they just exchange it among other farmers? Were new markets created, and so on? Okay, so I'm just going to sort of talk about sort of classes of results, and then I'll leave for any questions for the details for discussion later. So sort of the big picture question is that our prior that we should see magical takeoff didn't happen. The diffusion was at best modest. So even in treated villages were probably 2 percentage points more likely to adopt. So the adoption among non-recipient farmers, like any other farmer that was not part of the original sample, were only 2 percentage point more likely to adopt compared to the similar farmers in control villages where nobody received these seeds. And then you can see that so control villages in square dots are what is the normal diffusion curve, where if farmers they would adopt this technology on their own based on whatever is available in the market, anyone else promoting this technology from the government and so on. And even sort of that's the raw means, and just running the estimation. Also, you see a highly noisy estimate on the adoption level. Like I said, the difference between treated and control villages among non-recipient farmers is at the max 2 percentage points. if you look at sort of what happens in the subsequent longer run period, again the plateauing level is at the max 6 percentage points. So 6% of all paddy farmers are adopting it in control villages, and in treatment villages it's probably 8%. So it's not magical. Even after 5 years from the introduction, the adoption rate is only 10% at the max. And so then we look at, why is this, difference so small? Is it because are the access barriers, market structure, like how are they getting these seeds? To some extent, the treatment villages where the seeds were given to initial farmers, you do see some acquisition of seeds from other farmers within the same village. Not so much going on from, in control villages, farmers are more likely to get it from the market or, the block seed center, which is run by the government. So the treated villages have some advantage of, using within village farmers as a source of the seed. And so then we look at, okay, is it then reaching those that have a higher flood exposure? So those who are more likely to have flood prone land should be able to, because the seed provides insurance against downside risk. And so we do see, somewhat, better adoption among, more flood exposed farmers, but that's sort of occurring over time with a delay and so on. And we don't see much difference in the adoption among those with low. So to some extent, the adoption is a function of the technology choice, the attribute of the technology. Yes, the technology provides flood resistance. And so those farmers in these treated villages that have more flood exposed land are more likely to adopt it, but that doesn't come like as a head start. It comes sort of gradually, maybe because of learning, information, and all of that's going on. And so, so that's sort of the other side of the first result is, yeah, overall the average treatment effect is very small, and this could be because of the heterogeneity in the characteristics or the attribute of the the farmer's land and so on. So, but those who are more likely to benefit are adopting it much later. So then we look at okay, so we found this significance on seed source being local farmers. So then we are examining, okay, everything else held constant because the markets are accessible to everybody, government seed centers are accessible to everybody. But maybe there is something about the initial recipients and how the technology physically spreads in a village could be a function of the local social structures, like where farmers congregate, chat with each other, learn about the technology and so on. So then we looked at heterogeneity by village level social structure, which in India, for example, like, you have kinship in Africa, like in India, you have caste or jati system. So we look at specifically the key components of the caste, which are called jatis, which are specific groups. And then we kind of classify villages as having like, more jatis, like it's more fractionalized in terms of the social structure, or more homogeneous, where there are only like farmers from 2 or 3 jati groups. And that's where we see this, that's where our initial expectation of a huge head start and divergence kind of starts showing up, that in villages that were more homogeneous, you see a higher take up. And then that is happening, in the initial period. And these remember that these are non-recipient farmers, like because we did a census, and then that kind of advantage continues and you see somewhat divergent. But in villages where you have more jati groups, you absolutely don't see any kind of differential diffusion. And so then we look at, what's happening, how is the seed spreading between initial recipient farmers to these others to explain this head start. So then we look at, again, heterogeneity of individual farmers' adoption based on whether they belong to the same jati group as one of the initial recipients. Remember, the initial recipients were randomly picked from the farmers. And so there again, we see that farmers who have at least one farmer from their own jati group who receive the initial mini kits are more likely to adopt. So, and you see that in the earlier period, and you do see that persistent. The point estimate is kind of similar. So the 2 percentage point head start that we see comes from the fact that, you know somebody in your own social group who actually received this kit, and then, they probably tell you about their experience about growing this kit and the variety and so on. And then you can even physically get, hey, can I try some variety for myself and so on, right? Okay. And then that's sort of the core of the story. And then, lastly, we kind of wrap up by looking at, how do we target, right? Because that's sort of, I could find the recurring theme that, like, how do we increase adoption? Can we actually, is there specific targeting that could matter? So we do see that, like, farmers from dominant jati, like the social status of these initial recipient groups matter, but not in a, in a very easy way. Like, it's not that if you give seeds to the marginalized farmers who have a higher return, higher marginal return to the technology, that kind of spurs diffusion. But rather, if you give the technology to farmers from a dominant jati groups who have like some kind of social prominence, or in that sense of the elite farmer approach, that does seem to explain some increases in diffusion in treated village. But of course, it comes with a lot of caveat. So just to kind of summarize, and I know it's a short slot, we do see modest diffusion, like very small, which is like statistically insignificant, to gainful technology that in an impact evaluation has shown to be very promising, but then we don't see much amazing diffusion. And we kind of think about this as, the local social structures act as like market access barriers, so people are not able to learn or even like kind of try out seeds through seed exchanges. And it's also unclear if we want to like do any kind of specific targeting, because these social groups vary so widely. One thing we are able to kind of say that if you have villages or communities that are more homogeneous, then any kind of random seeding or even elite targeting, the targeting doesn't matter as long as those societies are homogeneous. It is going to take off. But if you have like more socially complicated structures, then we have to think more about how to optimally diffuse the technology. So that's where I'll stop. I'm happy to answer any questions or hand over to the next speaker. But thank you so much for this opportunity.
Thank you so much. Yeah, I think for time we'll go to Eric, but feel free people to leave some questions in the chat for Manaswini. Super interesting presentation. Thanks. Go ahead, Eric.
Can you hear me okay? Awesome. Yeah. Okay, yeah, so yeah, thanks for being here. Yeah, so when this is joint work with Anwa Wambugu at Strathmore University. When we started the project, we were both working on other things that were related to markets with low quality products. So our motivation was, agricultural input markets, but also broader than that. And the motivation is this idea that the lemons problem might be particularly challenging to address in lower income countries in a variety of markets. Agricultural inputs, I think, fits the bill because they often have characteristics that are really hard for buyers to observe. So one reason for this being a development question is often there's lower capacity to enforce regulations. So you have a regulator that might not have the staff or budget to monitor and enforce regulations. Even if you catch violators, weaker legal institutions might mean, there's a lot of corruption or courts are backed up and it's hard to actually punish violators. And separately, there are factors that slow information diffusion. So lower levels of education, less access to information technology might get in the way of mass diffusion in a way that could help address the lemons problem. So broadly speaking, abstracting from the particular setting, we're interested in how consumer information, so buyers knowing how to tell the difference between good quality and bad quality, how improving consumer information can help increase the quality of goods that sellers are supplying to buyers. So we want to know what are the effects on the quality that informed buyers get? Are they making better decisions? But we also want to know how that affects seller behavior. If the sellers know that there are more informed buyers, do they upgrade quality or change their pricing strategy? And the hope is that there are also benefits to buyers that remain uninformed, that if they're just buying what's available in the market, that they might benefit from the presence of other people that are informed. All right, so we're studying the hybrid maize seed market in Kenya. There are tons of reasons for under-adoption. We're focusing on consumer information in the setting. So hybrid maize seeds are a nice setting for this because it's not a great information environment. Farmers buy it infrequently. They get a noisy signal of quality each time that they plant because yields are so noisy. And in this setting, there's limited enforcement of regulation. So we're going to see a lot of variation in the quality of inputs that you see in the market. And I'll tell you more about that in a bit. So the possibility here is that if there's poor information, it could lower the quality of the seeds available in the market in equilibrium, and that could justify beliefs in lower returns to adopting improved seeds. All right, so what we do is we randomize a market level information intervention. And we do that because we're interested in the seller responses, understand how equilibrium in the market evolves. We randomly select rural markets to receive a community training. So we're gonna blast treated markets with information that help buyers detect high quality and low quality seeds. I'll tell you more about what that means exactly. In the end, we trained over 12,000 adults in this attempt to go as hard as we can, and which we would estimate being about 9% of buyers that typically buy seeds in these markets. And of course, an unknown number got the information secondhand, which we also encourage people to do to spread information to friends, family, etc. Then we did surveys with buyers and sellers and did secret shopper activities to see buyer and seller behavior for a little over a year, so over 3 planting seasons after treatment. Okay, so in the paper, we have a simple model just to fix some ideas about what you would expect if you did something like this. So imagine there's a local village seller that offers low quality seeds at baseline. And we want to know what would you expect to happen in response to a large increase in the number of informed buyers that can distinguish between low and high quality products. I want to present 2 different scenarios. One scenario where it's cheap for the seller to upgrade quality from low to high quality. And in this world, when they're faced with a lot more informed buyers, they're incentivized to upgrade quality. And that's going to draw in more buyers to buy locally rather than leave the village to buy seeds in town. In scenario 2, upgrading quality is very expensive for sellers. So they're faced with a lot more informed buyers, but it's not profitable to upgrade quality. Instead, the seller opts to exit as they lose customers that are opting for an outside option, buying seeds in town rather than locally. Okay, so I'm not going to motivate. We all know why increasing seed quality, access to high quality seeds is important. I'll tell you more about the setting in Kenya, where agricultural inputs are regulated by a parastatal called KEPHIS. So seeds need to be certified by KEPHIS, seed sellers must be registered, but they have almost no capacity for monitoring at the retail level. Most of their activities are at the seed manufacturing level and at the wholesaler level. So they don't go around and monitor the kind of sellers that we're going to be focused on here. We're doing this in 4 counties in Western Kenya, and we randomly selected small to medium-sized rural markets and surveyed seed sellers at those markets and households within a kilometer of those markets as likely customers. About half of them will tell us that they normally shop at that market, so they are likely customers, but we're not capturing everyone that usually shops in these markets. And in general, we're focused on the lowest level of the supply chain, that these small retail shops. You should think about a kiosk with 2 employees. And some key examples of the kind of seeds we're focused on are deceptive counterfeits. So they look like genuine seeds, but they're not. They're manufactured by counterfeiters. They're expired seeds, which are genuine products, but they're not supposed to be sold because they're past their use-by date. And then there are gray market uncertified seeds. So maybe they came from the manufacturer, they didn't pass some inspection, but they still ended up on the market somehow. Here are 2 packets that we purchased from a pilot market. It's the same manufacturer, Western Seed Company, the same variety, WH101. The packaging looks a little different, and we'd recommend farmers to buy the one on the right. It has a certification sticker that's required. If you use that sticker, you'd see that it's a valid sticker. This isn't something we trained on, but this also has some typos here. This is a suspected counterfeit over here. If you were to look at the bottom of the package and you knew to look here and you knew what these dates meant, you would know that these are packaging dates and that you should add 1 year, you should add 12 months to the date to get the expiration date, and you should see if they were expired, and they are, because we bought them in late 2019 for piloting. So if you can, we'd advise a farmer to not use any of these packets and go to a different market and try to find better seeds. So these are the kind of things we're training farmers on. Overall, about 57% of packets had all the quality markers that we recommended farmers look for before they purchase seeds. And packets that have all the markers in lab tests for germination rate perform significantly better, about 5 percentage point better germination. Okay. For time, let me skip some of this and just show you quickly. This is the English version of a flyer that we use to help train farmers, and including how to use this kind of obscure looking sticker with no instructions on it, which actually gives you a lot of information and is very difficult to fake. Similar to in Manaswini's paper, we recruited elite farmers to help spread information, but we're not studying the information spread. We're just using it to try to, spread information as far and wide and intensively as possible. We also, for every baseline surveyed farmer, we gave them the information treatment after completing the survey at the very end. And we did 1, 2, or 3 days of basically a staff member walking around, talking to as many people as possible within the study area. Baseline covariates were balanced, and we also did an activity with pure control markets with no baseline surveys, in case surveys asking people about their planting practices affects behavior. Okay, now the empirical findings. First, we found increased knowledge and usage of quality markers. So we did a phone survey to test knowledge. I think the impacts were a bit smaller than we expected, but it was also a phone survey about a few months after we wanted to due to COVID disruptions. Yeah, so increased knowledge and self-reported usage of using the quality markers to buy seeds. We saw some changes in purchasing decisions. For example, treated farmers were less likely to buy hybrid seeds at their local market and more likely to buy elsewhere. So evidence that they're using this outside option to buy in town, but no significantly different propensity to buy hybrid at all. And in this setting, in the main season, about 90% of farmers do use hybrid seeds. So that's maybe not the margin that we're going to see effects. We see agricultural gains from treated farmers. And these are all, not only in treated markets, but they got the information treatment because every respondent did. So about 6% increase in self-reported yields. One caveat is we don't measure changes in other inputs. Like we can't rule out that they spent more time farming with more labor inputs. So it's possible that treatment crowded in more labor. We can only check if it affected fertilizer use, and we don't see evidence of that as the one kind of other main input that we included in the survey. On the seller side, we saw a fairly strong seller exit effect. So about 1 in 6 or 7 sellers on net exited. It doesn't mean they went out of business. It meant when a secret shopper went to try to buy seeds, there were fewer sellers that had seeds in stock. And lastly, we didn't see impacts on the frequency of seeing quality markers or the purity and germination rates of seeds that secret shoppers purchased and that we tested in the lab. Likewise, no effects on prices or the dispersion of prices, in case you thought that the information treatment could have caused a separating equilibrium with higher quality seeds selling for more and lower quality seeds selling for less, which is illegal, but could happen. Okay, so I'll say a few things about policy implications. So I think that's the naive way to think about it is first to think about the cost effectiveness of exactly what we did in the paper. I think so. The paper showed that quality certification can help increase agricultural productivity. And so one thing you could do is scale up these kinds of community trainings. It was cost effective in the sense that it was very cheap to have one person walk around telling people things and hand out flyers, and could be justified by a 1% increase in yields. It doesn't include the cost of the regulatory structures that we're piggybacking off of in order to do this treatment. And maybe you have questions about how this can be, if this would be effective targeted at scale, because we are using features that maybe would be fraudsters could adapt to, like faking expiration dates, for example. Probably there's some low-hanging fruit in using mass media. Definitely on the packaging, it was very cryptic with no instructions or guidance for consumers, many of which are illiterate, to use it to understand things like, for example, there's no standardization of expiration dates. So that seems like low-hanging fruit to improve consumer information. Now, the failure, the way the results didn't meet our expectations was sellers behaved as if the upgrade costs were very high. They didn't upgrade quality. So one question is why? And I'll highlight that these takeaways are quite different from the policymakers' mental model, where they imagined you don't need consumer information. Sellers will be jumping to share the information themselves to outcompete other sellers that are selling low quality products. And in contrast here, the information treatment hurt sellers across the board, and they didn't upgrade quality, even when someone else came in to spread information. Yeah, so to conclude, it's one of the few experimental studies operating at the market level to study the impacts of consumer information about product quality. We saw that informed buyers responded and benefited, but even this large one-time campaign didn't discipline sellers in the way we want. It didn't drive out the uncertified seeds. And I like the paper because I think the findings are probably relevant to a lot of other product markets where consumers can't learn about quality of goods very easily. So for example, in this setting, also electronics, contaminated foods, counterfeit medicines are big policy issues. Great, thanks.
Awesome. Thanks, Eric. We have about 3 minutes if anybody has a question they would like to ask. Bear, go ahead.
Oh, that was applause. But if others don't have a question, if others don't have a question, I do have one. And that is if you have a sense of maybe how sort of market structure and how farmers at baseline perceive input sellers sort of, as probably these bad business people who try and exploit them, and maybe who might collude with one another. If sort of that could somehow influence in this market the impacts, and if there was more of a sort of positive relationship between farmers or more of a relational contract, if that would have, sort of different effects. Yeah.
Yeah, one thing we did check, which I was curious if there'd be differential effects by, is some farmers rely on their seller to provide credit, so they have an ongoing relationship where they buy seeds on credit. We don't see differential effects by that. Maybe they'd be less likely to switch, for example. In terms of like trust or collusion, yeah, I'd really like if anyone has like links to literature. I mean the best reference I have is Laura and Falcao's paper on maize sellers on collusion. These are seeds, but I am thinking about these as like single seller markets, and when there are multiple sellers, they may collude and behave as single sellers rather than compete in the way the regulators kind of expected, in a way where the competition effect could lead to high quality being offered. We don't really see evidence consistent with that, but it's a little bit hard to tell if they're colluding.
Very interesting work. Thanks.
Thank you. Well, I think that just about brings us to time. So I just want to quickly thank all the speakers again for really great presentations, as well as thanking the audience for attending. I'm sure the speakers would be happy to get more comments later if you think of them. And yeah, thanks everyone for being here. Have a nice weekend.
Thank you. Thank you
And
for
thanks, Carly, for organizing this,
Thank
and
you.
the AEA for having us.
Thank you, AEA.